Welcome back to part 2 of the choke effect. Today, we are looking at the 3 distinct psychological triggers that cause us to fail under pressure: dangerous overarousal, distraction, and explicit monitoring. Economists and psychologists have long operated on an assumption called the efficiency wage model. The logic seems straightforward: offer a higher reward, generate higher motivation, and produce better performance. But if you observe how human beings actually operate in real, high-stakes environments, that equation frequently falls apart. Take the 2004 Athens Olympics. In the men's 50-meter rifle event, American shooter Matthew Emmons was exactly 1 shot away from securing a gold medal. He aimed, fired, and hit a perfect bullseye. The only problem was he aimed at the wrong target. 4 years later, at Beijing 2008, Emmons found himself in the exact same position. He needed a highly manageable 6.7 score to win gold. He pulled the trigger and registered a 4.4, a shot ridiculously below his own proven standards. Dangling Olympic gold or the threat of severe public failure in front of someone certainly provides motivation, but it also induces a massive spike in psychological stress. That intense pressure physically alters how different networks in our brain communicate with each other in 3 highly specific ways. When a performer chokes, we tend to view it as a failure of courage or an evaporation of talent. What the data actually shows is a predictable, split-second neurological glitch triggered by extreme pressure. That brings us to the first mechanism: over-arousal. This happens when the brain's reward and motivation centers experience a severe physiological overload. When researchers place subjects in an fMRI machine and offer them high incentives, like a massive sum of cash or an Olympic medal, they watch the midbrain and the striatum glow intensely. These regions are flooded with dopamine as the brain registers the potential reward. But as the stakes climb higher, the excitement of winning collides with the fear of losing. This triggers an extreme threat response. The hyperexcited midbrain begins firing so aggressively that it actively overrides the prefrontal cortex, which serves as our main executive control center. The brain essentially becomes so flooded with fear signals and its own internal hype that it can no longer maintain executive control, ruining physical execution. While overarousal dismantles physical execution, the second glitch, distraction, specifically targets high-level intellectual tasks, like taking the SATs or working through a complex math exam. To solve these kinds of intellectual problems, we rely on working memory. Think of it as a mental scratchpad with a strictly limited capacity, designed to hold and process complex information in real time. This chart shows exactly what happens to that scratchpad under pressure. The stressful environment floods the working memory with task-irrelevant cues and creeping worries. As thoughts like, "What if I fail?" consume those memory blocks, there is virtually zero space left over to process the actual task. The data reveals a cruel irony. This glitch harms highly qualified individuals the hardest. Top performers achieve their results because they rely on a deep reserve of working memory. When anxiety steals that reserve, their primary advantage disappears. Anxiety physically steals the cognitive workspace required to process information, causing devastating performance deficits on intellectual tasks. The third glitch takes us out of the classroom and back to physical sensory motor skills, exposing a major difference in how experts and novices operate. Highly practiced individuals rely on procedural memory, which acts as a neurological autopilot. After thousands of hours of practice, they develop what psychologists call expertise-induced amnesia. They do not consciously remember the step-by-step mechanics of their actions because their bodies automatically know how to execute them. Novices, on the other hand, rely on declarative memory. They have to consciously think through every single physical step of a movement: plant the feet, bend the knees, keep the head down. To see what happens when pressure interacts with procedural memory, researchers designed a study focusing on expert golf putters. They found that when extreme pressure is applied, experts panic. Their mental processing shifts away from automatic execution and reverts back to conscious step-by-step control. Psychologists call this explicit monitoring. To test this further, researchers ran the funny putter experiment. They handed experts a weirdly shaped, arbitrarily weighted putter that forced them to consciously think about their stroke mechanics. Stripped of their autopilot, the experts' accuracy immediately dropped to the level of absolute novices. Stress forces the expert brain to manually override its own perfectly tuned autopilot. This causes elite performers to neurologically regress, replacing smooth execution with the jerky, inefficient movements of a beginner. Choking under pressure is not a reflection of a person's bravery. It is a severe misallocation of neurological resources, where attention is temporarily hijacked by stress. Fortunately, we can hack these glitches. To combat distraction before a major exam, psychologists point to a behavioral intervention called expressive writing. By spending a few minutes writing down your thoughts and fears about an upcoming test, you physically dump those worries onto paper. This offloads the anxiety, clearing out your working memory so your brain has the room to process the actual task in front of you. For over-arousal and explicit monitoring, the fix is reappraisal. This chart illustrates how a stress signal normally leads to a panic response. But by consciously reframing physiological signs of panic, like sweaty palms or a rapid heartbeat, as your body simply powering up for the challenge, you divert that signal. You keep your executive control network online and engaged. Remember, the battlefield of high pressure is entirely in your head. Thanks for watching, and we'll see you next time.